In this video, we'll look at halocarbons by exploring their uses, chemical properties, exposure limits, and first aid measures. There are many halocarbons available, so we'll summarize and zero in on some that are currently or have historically been used as refrigerants. Halocarbons are man-made compounds. The term halocarbon is shorthand for halogenated hydrocarbon. A halocarbon is a hydrocarbon compound that has replaced at least one hydrogen atom with a halogen atom. It might surprise you to learn that halocarbons have been used for many purposes outside of refrigeration. Some halocarbons have properties that make them useful as a solvent. Due to environmental restrictions, however, halocarbons are typically no longer used in this function. Halocarbons are effective fire suppression agents. When released from a fire extinguisher, halocarbons will rapidly evaporate to help starve out a fire. Because of their non-toxic and non-corrosive properties, halocarbons are generally considered safe for humans in this application. Additionally, halocarbon fire extinguishers generally cause less damage than dry chemical fire extinguishers. Since the 1920s, halocarbons have been successfully employed as refrigerants. Halocarbons are generally non-toxic and non-flammable, which made them popular choices over natural refrigerants such as ammonia and hydrocarbon refrigerants. Halocarbon refrigerants have good thermodynamic properties over a wide range of temperatures and pressures. Halocarbons boil at various temperatures. Based on the chemical formula, each compound has a different boiling point at atmospheric pressure. The table on the screen displays the boiling point for some common halocarbons, natural refrigerants, and unsaturated hydrofluorocarbons, or HFOs. In all instances, the refrigerant boils at a temperature below what is typical on Earth. This means that in all but the most extreme winter conditions, halocarbons will not remain a liquid, but will be in a gaseous state. This is important to understand because if a leak occurs from a pipe containing liquid halocarbon, the refrigerant will rapidly escape and expand into vapor form. Halocarbons are always heavier than air. This is not ideal, since it means that during a leak, halocarbons will tend to accumulate near the floor, replacing the oxygens humans need to survive. The relative vapor density for several refrigerants are shown in the table on this screen. Vapor density is a unitless number that compares the weight of a vapor to the weight of air. As you can see, all of the halocarbons are at least 3 times heavier than air. Most common halocarbon refrigerants are non-flammable and non-toxic, which has been a primary advantage over ammonia throughout the years. ASHRAE Standard 34 is titled Designation and Safety Classification of Refrigerants. Among other things, this standard assigns each refrigerant a safety group classification based on the refrigerant's flammability and toxicity. Class A is assigned to refrigerants with low toxicity, and Class 1 is assigned to non-flammable refrigerants. This table depicts the safety group for several common refrigerants. Notice that all the halocarbons shown have an A1 classification. Even with a classification of A1, a slight fire hazard can exist with halocarbons. This is because halocarbons are soluble and miscible with oil. This means that halocarbon refrigerants and oil will readily mix. When a leak occurs, the escaping refrigerant may have a percentage of oil, which could be ignited. It is important to know what concentration of a chemical vapor is safe for humans. Exposure limits, such as NIOSH's recommended exposure limit, REL, or OSHA's permissible exposure limit, PEL, are the limits of exposure to a chemical substance that are considered safe without respiratory protection. Due to their non-toxic nature, most halocarbons have much higher exposure limits compared to ammonia. The table here displays the exposure limits obtained from the safety data sheets of several common refrigerants. If you are exposed to a halocarbon, it is important to implement first aid measures immediately. Inhalation is the most common route of exposure to a halocarbon refrigerant. Exposure to low concentrations of vapor can typically be addressed by simply moving to fresh air. If high concentrations were inhaled, medical aid must be sought out. When skin contact with a liquid halocarbon occurs, the affected area must be immediately flushed with water for at least 15 minutes. Care should be taken when removing any clothing, as the halocarbon may have caused the material to be frozen to the skin. After flushing is complete, seek out medical aid. The eye is a particularly sensitive organ and must be protected from chemical exposure. If eye contact occurs, utilize an eye wash or a face wash station to flush the eye for at least 15 minutes. After flushing is complete, seek out medical aid. Halocarbons are readily available from refrigerant suppliers. Halocarbons have historically been more expensive than natural refrigerants such as ammonia. In recent years, the price of halocarbon refrigerants has skyrocketed due to restrictions on manufacturing and importing halocarbons. Halocarbons are considered odorless, so leak detection is more difficult compared to ammonia. Technicians, therefore, must utilize an electronic leak detector or halide torch to find a leak. A halide torch works on the principle that a flame changes color when exposed to a halocarbon gas. A slight halocarbon leak will change the color of the flame to green. A larger leak will turn the flame to purple. Extremely high concentrations of halocarbons will extinguish the flame. Many electronic gas detectors are available for detecting halocarbon leaks. These can be interlocked with alarms to notify personnel when a leak has occurred. In general, halocarbons do not react with other chemicals, and unlike ammonia, halocarbons are compatible with copper. As a result, copper is widely used as a material of choice for piping and heat transfer services in halocarbon systems. In a fire, halocarbon refrigerants may break down into their dangerous compounds. Even a small flame or hot surface, such as a halide torch or soldering iron, can cause this to occur. Typically, these dangerous gases have an odor, which is a good warning that such a breakdown has occurred. Halocarbons are heavily regulated because of their ozone depletion and global warming potential. The United States signed on to the Montreal Protocol in 1987, which led the way to the Clean Air Act in 1990. The Clean Air Act has given the EPA authority to restrict use and phase out refrigerants deemed harmful to the environment. To legally work on halocarbon-containing equipment, a person must first become certified by an approved organization. Major penalties can be imposed for improperly handling halocarbons or venting them into the atmosphere.